Imagine a world where the heat we typically waste could power our future. This isn't science fiction, it's the promise of waste heat recovery technology, a game changer in our fight against climate change. Every day, industries around the globe lose vast amounts of energy as heat. Power plants, factories, and even our vehicles release heat that simply dissipates into the environment. But what if we could capture this heat and put it to use? This is the essence of waste heat recovery. At its core, waste heat recovery is about reclaiming thermal energy that would otherwise be lost. Traditional power plants, for instance, convert only about 40% of their fuel into usable energy. The remaining 60% is lost as heat. Waste heat recovery systems can capture this heat and redirect it for practical purposes, such as generating electricity, warming buildings, or powering industrial processes. The potential impact of this technology on our climate goals is staggering. The International Energy Agency estimates that recovering and reusing industrial waste heat could offset up to 20% of global industrial energy demand. This translates to preventing the emission of hundreds of millions of tons of carbon dioxide annually. Waste heat recovery also complements renewable energy systems. By integrating this technology with solar and wind installations, we can address challenges like intermittency and improve overall efficiency. Moreover, district heating systems could incorporate industrial waste heat to dramatically reduce reliance on fossil fuels for heating buildings. Despite its immense potential, waste heat recovery remains underutilized in most industries. Many companies are unaware of its benefits or hesitate due to high initial investment costs. In the United States alone, industries waste over 1,000 terawatt-hours of energy annually as heat. This equals approximately 15% of the nation's total energy consumption. However, a wave of technological advancements is changing this landscape. New heat recovery systems have become more efficient and cost-effective. One exciting development is the integration of combined heat and power systems with fuel cells, achieving efficiency levels over 90% in some cases. The applications of waste heat recovery span across various sectors. Data centers could repurpose their operational heat to warm nearby buildings. Urban heating networks might integrate waste heat from factories or incineration plants. In the transportation sector, emerging technologies can recover heat from engine exhaust to improve fuel economy. Perhaps one of the most critical applications lies in clean hydrogen production. Capturing waste heat from industrial processes could supply the high temperatures necessary for hydrogen generation via electrolysis, potentially accelerating the adoption of green hydrogen as a zero-carbon fuel. The case for implementing waste heat recovery is urgent. With climate deadlines approaching rapidly, industries cannot afford to ignore this underused resource. Sectors with high energy consumption should prioritize investments in heat recovery technologies to reduce emissions and save costs. Looking ahead, widespread adoption of heat recovery could play a central role in decarbonizing the global economy. By harnessing existing energy more efficiently, waste heat recovery presents a powerful tool to promote a sustainable energy future while addressing the pressing demands of climate change. The heat we once wasted could very well be the key to powering our path to a net zero world. Thanks for joining us for the latest in energy science. What are your thoughts on turning wasted heat into a resource? Share in the comments and hit subscribe for more exciting topics. See you next time.